A warm welcome to all the viewers for the course Advanced Manufacturing Technology. And today myself Thiapal, Assistant Professor of Department of Mechanical Engineering, JIS College of Engineering, is going to give a brief lecture on selective laser sintering. Well, in my previous lecture, I have already explained you about rapid prototyping, and you all are aware that how rapidly it has been played an important role in today's advanced manufacturing field. We all are aware of non-traditional machining processes also, where you can see that in conventional machining process, it is difficult to machine some material. They are basically preferred for machining in non-traditional machining process. Similarly, if I talk about rapid prototyping, then I must say this is the advanced form of machining. And the thing is that here the material is basically formed or basically structured with the help of three different processes. Either it can be additive process, either it can be subtractive process, or either it can be a virtual process. So today we are talking about stereolithography. Already in the last lecture we have talked about stereolithography process, and today we are going to discuss about selective laser sintering. So before we proceed with the lecture, let's have a look at the content. So all of you just have a look here. Today we are going to proceed with this particular parameters. One is introduction. Next we will be discussing about working principle, and then we will be defining the type 1 type 2 types, this working principle, as well as we are going to discuss about the materials, their advantages, disadvantages, as well as application. So without any further delay, let's have a look at the introduction portion. So we are talking about selective laser sintering. Now, selective laser sintering is basically a process which is based on sintering of non-metallic, or you can say less or commonly metallic powder selectively into an individual object. And the basic element in this process will be represented in my next slide. Now, the bottom of the processing chamber is basically equipped with two cylinders. One, a powder feed cylinder which is raised incrementally to supply powder to the parts build cylinder through a roller or mechanism. And next, a part of building chamber which is lowered incrementally to where the sintered part is going to be formed. So, if I talk about selective laser sintering, then you can see that it uses laser beam to selectively fuse powder. Powder of what? Powder of materials like nylon, elastomer, or metal into a solid object. Now, parts are to be built on a platform which is slide below the surface in a beam of heat fusible powder. So, there must be some beam, and in beam what is there? There are some powder, and this will be the platform which will sit just below the surface in a beam of heat fusible powder. Now, laser traces the pattern of the first layer and sintering it together. So basically, initially it has to trace the pattern of first layer, and then sintering is performed together. Then platform is lowered. Slowly the platform is further lowered, and the powder is reapplied and process is repeated. So you can see how basically the selective laser sintering is playing an important role in producing the part. Now let's have a look for the next slide. Now if we discuss about the working principle, then what is the thickness of the layer it can be performed? It is basically 0.1 millimeter thick. and the part building take place inside an enclosed chamber which is basically filled with nitrogen gas to minimize oxidation and degradation of the powder material. If the powder is open, then what it will happen? It will come in contact with the oxygen or the impurities that are present in the atmosphere. To avoid all this type of degradation of the powder material or to minimize the oxidation, the entire parts is boiled inside an enclosed chamber which is basically filled with nitrogen gas. So this is very important that you have to remember. Next, the powder in the building platform is basically maintained at an elevated temperature which is just below the melting point or glass transient temperature of the powder material. So again I am repeating, the powder in the building platform is basically maintained at an elevated temperature which is just below the melting point and glass transition temperature of the powder material. Next is that infrared heater are also used. Why? To elevate and maintain the temperature around the parts that is going to be formed. So a proper temperature maintenance has to be performed all throughout the process. Otherwise it will be difficult to form the product or to form the part. So infrared heater is also used to maintain an elevated temperature around the part being formed. Next, what we are going to do in this particular process, it is a focused carbon dioxide laser beam is moved on the bed in such a way that it thermally fuses the material to form the slice cross section. So material is laid over the bed and you are going to focus carbon dioxide laser beam over the bed in such a manner that you are going to thermally fuse the material and you are going to form the slice cross section. Now surrounding powder remain looses, okay, and serve as a support for subsequent layer. So where the laser light is focused, in that particular material only thermal fuses occur of that particular material, but remaining powder basically remain loose and it also serve for subsequent layers. So if I conclude from this overall working principle, then I can say that we are building some parts and that parts are built in a closed chamber which is basically filled with nitrogen gas. Why with nitrogen gas? To minimize the oxidation and degradation of the powdered material. Now this powder is building platform has to be maintained at some elevated temperature. At that temperature should be below the melting point or glass transient temperature of that particular material. If it is not below the melting point, then it will be getting melted, and if it gets melted, then you are not going to get or obtain the desired product. So you have to keep in mind that the powder in the building platform, it has to be maintained some elevated temperature or the glass transient temperature of the powder, and that should be below the melting point or the glass transient temperature of the powder material. Then there must be an infrared heater. This is used because to elevate the temperature around the parts you are going to form or you are going to produce. And finally what you are going to do is that you are going to focus a carbon dioxide laser beam over the bed in such a way that thermal fuses the material to form the slice cross section. And one important thing is that it is very interesting that the powder which are surrounding the object, it remains looses and it also serves as support for subsequent layer, because ultimately whatever we are going for the rapid prototyping process, It can be in case of stereolithography also. It can be for selective laser sintering also. The material we are depositing is layer by layer. In stereolithography, you are just using some liquid photopolymers, but in selective laser sintering, you are using the powder. It can be non-metallic or it can be less metallic. Basically, non-metallic powder are preferred to carry out this particular process. Now, let us move to the next slide. So, just have a look the working principle. What you can see is there. This is the particularly laser source, and this laser is what? This laser is your laser carbon dioxide. Then you can see here a species. That means laser light is coming, it is getting strike over the species, and you can see this is your regulator. And this you can see what? Stratosotidi polymer. So, this is the where you are ejecting this particular portion. Okay. And you can see this is the roller, and this roller is just getting over this particular, this is one of the powder feed cylinder. This is a roller, and you can see this is basically you can consider as process chamber. This particular portion you can consider as your process chamber. So, this is basically a component die base, and you can see how a product has been formed. This is a product you can see that has been formed with the help of this particular process. And this is what, if you have seen some drill bit, then you can see this cutting edge, you see. So, now let us move to the next slide. So, this is basically a schematic diagram through which I am going to illustrate you the selective laser sintering process. So, before we move with the process, let us have a look at the component that are associated with your selective laser sintering process. So, first we are going to talk about the laser, because laser is the one which is going to provide you the laser light, so that you can solidify the material. This is your optic. Then with the help of this one you are getting a galvanometer, and every process that it has to be carried in this particular situation, it will be controlled by a computer. It is process control computer. Okay, so this from process control computer you are sending the signal to laser, to optic chamber, and then it is going for galvanometer. And this is one of the most important thing, that is environmental control unit, so that no hamper can occurs in the environment. So, there is the environmental control unit, and this entirely process is basically occurring in a process chamber which is basically filled with nitrogen gas. Why? To minimize the oxidation. Okay, so this is a process chamber. You can see this is a roller mechanism is there, because this roller is sliding over this particular thing, and the two cylinder is located. One is powder feed cylinder, another is part produce or part build cylinder. So, after here producing the part, after just rolling, you are producing the part over here with the help of this laser light. It is focusing over the project. So, then it has been come in this particular cylinder, that is the part build cylinder. And to feed the powder cylinder, there is also a motor, and here is also a motor which has been used to connect with the process control computer, as well as from here also it is supporting the part building cylinder. So, now let us get into the brief discussion about this particular working principle of selective laser sintering. So, as I was talking, that is the basic element in this particular process has been shown in this particular figure. So, if you just have a look at the bottom of the processing chamber, it is basically equipped with two cylinders. One is powder feed cylinder, another is pad build cylinder. So, a powder feed cylinder which is raised incrementally, means slowly it has been raised incrementally to supply powder to the parts build cylinder through a roller mechanism. So, roller mechanism you can see here, and parts had been raised slowly over this particular process so that you can obtain the product. Next, we are talking about the part building cylinder. A part building cylinder which is lowered incrementally. So, you just have a think, this is raised incrementally slowly, and this part build cylinder is lowered slowly. It has been lowered slowly. So, one it is raising, another it is lowering to where the centered part is going to be formed. Now, a thin layer of powder is first deposited in the part building cylinder. So, here you can see powder is there. The roller mechanism is using, this is the roller which is used for roller mechanism, and slowly the powder it is basically deposited over part building cylinder. Next, a laser beam guided by a process control computer using instruction that has been already generated by the 3D CAD. So, as I have already told in the first lecture of rapid prototyping that how you are going to carry out the entire process. So, there you know we have already mentioned about the 3D programming generation of what? Of the desired part, and this is then focused on the layer and tracing and centering of a particular cross section into a solid mass. So, you can see slowly the powder feed is getting raised. The roller is used to put the powder over the part build cylinder. You have already generated the 3D programming to get the desired part, and the thing is that then with the help of this laser light or laser beam, okay, it is focused on the layer, it is tracing, sintering a particular cross section into a solid mass. So, here you can obtain a solid mass also. Now, the powder is another areas remain loose. Now, all the powder is not getting solidified or getting into a solid mass. The remaining powder is still there which is remaining loose, yet it supports the centered portion. So, where you are performing the centered operation, it is supporting your centered portion also. Now, another layer of powder is now deposited. As I have told, this particular process is all about depositing layer by layer. So, here you are depositing another layer of powder, and that is also in the layer form. Now, this cycle is repeated again and again until you obtain the entire 3-dimensional part. So, as we are talking about deposition of material, that is also layer by layer. You can see that another layer of powder is deposited through this cycle, and you can see repeatedly it has been performed unless and until you get the entire 3-dimensional part that is required, or that is your ultimate product. Now, the loose particles are then shaken off and the part is recovered. So, from the part build cylinder, what you are doing is that you are removing the product, and if there is some sort of loose particle that has been attached to the product, it has been shaken off. Now, the part does not require further curing. Curing means hardening, unless it is a ceramic, because if you are dealing with non-metallic, you need to go for hardening process or curing process for further. But if it is ceramic, then you are going to use the curing or hardening process too. Now, a variety of material can be used in this particular process, and it includes polymer like ABS, PVC, nylon, polyester, polystyrene, epoxy. So, about this all material, I think you have already gone through in your engineering materials where you have studied about all this particular material, their composition, their melting temperature, their properties, isn't it? So I am not discussing about this particular material in this lecture. Okay. Next, if I talk, that is, which of the common polymer is mainly used? So my answer will be wax, metal, ceramics. All these are basically appropriate binder, and material that you are using, it includes polymer, which is just like ABS, PVC, nylon, polyester, polystyrene, epoxy, and with the help of wax, metals and ceramic, which has to be considered as appropriate binders, it is commonly, or it is most common to use polymers. Okay, because of the smaller, less expensive, less complicated laser required for sintering. So when you are performing the sintering operation, you have to keep in mind that which polymer is much effective or which material is much effective. So my suggestion for that is polymer, because it is very smaller, it is less expensive, it is less complicated and laser required for sintering. Now with ceramic and metal, it is common to sinter only a polymer binder which has been blended with the ceramic or metal powder, and then to complete the sintering in a furnace. So if you go with the ceramic and metal, then it is very common to sintering only a polymer binder which has been already blended with the ceramic or metal powder, and then it has been used to complete the sintering in a furnace. So hope you have understood the entire process of selective laser sintering from this particular figure. So what you are doing is that preferring the polymer for generating the product. You are basically using the binder as wax, metal and ceramics. These are the appropriate binders. Powder feed cylinder is slowly getting increased, and part building cylinder it is slowly getting decreased, means decreasing incrementally. And with the help of this roller, the powder is used to get over the part building cylinder, and with the help of laser beam, the sintering it is performing. So this is the basic working principle of selective laser sintering, and there is entire process is controlled by your process control computer. Now let's have a look at the next slide. So you can see selective laser sintering, and you can see this is the structural nylon parts that has been produced, and this is the structural part that has been produced by super alloy material. So this is direct metal fabrication, and this is selective laser sintering. With the help of that you are getting the desired product, and for direct metal fabrication process DMF you are getting this particular product. Now we are going to talk about the type 1 type and type 2 type for selective laser sintering. Now if you are producing the 3D system and it is carried out by USA, they are preferring type 1, and basically type 1 was developed and patented by University of Texas, which is in Austin. Material they have selected, that is only technology that is directly processed, like thermoplastic, metallic, ceramic and thermoplastic composites. Now which model they have preferred? That is Sinter Station 2000, 2500 and 2500 plus Vanguard. So these are the model they are preferring to perform type 1 selective laser sintering process, and it was developed by 3D System in USA and further developed and patented by the University of Texas, that is in Austin, and material they have preferred for thermoplastic, metallic, ceramic, plastic, thermoplastic, composite. Now this is the process of type 1. You can see this is powder bed, this is powder bed. This is the product that has been built up. So this is the powder bed on build up position, and this is the excessive powder take up. You can see there is a carbon dioxide laser is provided. This laser is ejected over the scanning system, and slowly it has been focused. It has been focused over this particular powder bed to build the product. Now this is a roller. You can see slowly it is getting increased, so that this powder can be rolled with the help of this roller. This is basically your roller mechanism, and the entire thing is conducted in this chamber. It is a temperature controlled build up chamber with nitrogen atmosphere to avoid oxidation or any degradation of the product. So this I have told you in little bit in the previous slide, but with the help of diagram I am explaining how the product is formed. So this is the basically the product that has been generated, and you can see layer by layer, the deposition is layer by layer. So ultimately what we get is that the product, through the rapid prototyping, the deposition of material is basically occurring through layer by layer process. Now that was the figure. Now if you see this 3D object, you can see this is basically feed cartridges, this is also feed cartridges, this is the build platform over which the product has been built. Okay, so this is the roller that is used to roll up the powder over this particular platform. There is an eye or heater is there, so that easily it can be centered. Now carbon dioxide laser, there is a scanning mirror which is used to focus the laser beam over that particular powder to obtain your desired product. So it is very clear from this particular figure, it is very clear, crystal and clear, the process to you. Now let us have a look for the type 2 process. Basically it was produced by EOS, by German, and later first European for plastic and manufacturer they have preferred. Cable to be provided is of 700 into 380 into 580 millimeter. Now this is first worldwide system for direct laser sintering, and the model they have preferred, it is EO-SINTP model for thermopress plastic material, example for nylon, and they have used EO-SINT-M model for metal, and they have used EO-SINT-P 700 for plastic material. So three different materials, they are using three different model. One is EO-SINT-P, EO-SINT-M model, EO-SINT-P model of 700. So you can see this is the process. Animation video cannot be played here, okay, and this has been performed for ESO-INT for M and S machine. You can see this is the laser light that has been focused here. Now what are the involvement that are associated with this particular process, type 2? First of all, local melting and sintering of the powder by laser. Second, directly if I consider, then the powder particles melts together. But if I discuss about the indirect, then the powder particles are coated with a thermoplastic binder which melts up. Now what are the characteristics of this particular process? So if I have a look here, first of all, first characteristic is it's generally produce high part complexity. Many materials are available. Burning out the binder and infiltration might be required, and relatively high porosity and surface roughness you can obtain, and usually no support needed. So these are the characteristic of type 2. These are the characteristic of type 2. It is type 2 selective laser sintering process. So this is the process. Initially what I was talking, this is your process principle. Again you can see the laser light, it has been focused over this one. This has been carried out in a chamber. This is SLS of plastic, that is the computer mouse. You have seen the computer mouse, isn't it? And this is of SLA of metal injecting molding insert, and this is of SLA of sand. This is core for the sand casting. You can see core for the sand casting has been generated. What are the materials that are preferred for selective laser sintering process? It is wax, thermoplastic, metal, casting sand and ceramics. Now there are certain advantages. So we are going to discuss the advantages for type 1 and type 2. So if I consider for type 1 3D system, then the thing is that it is good path stability, precise control environment and wide range of process material like nylon, polycarbonate, metal etc. can be preferred. No part support is required, I mean to say material as a support, and little post processing is required, that is blasting and sanding, because if the sand is there associated with that product, then the blasting and sanding is also required, and no post curing or hardening is required because the model solid is enough. Now if I will have a look for the advantages of type 2 EOS, then good path stability, and it is precisely environmental control, and wide range of processing material they are preferring for polyimide, polystyrene and metal. No parts support is required, or only simplified support reduce the building time. If you provide a simplified support, then it will reduce your building time. And little post processing is required to obtain a good model finishing. The accuracy level high, there is high accuracy level, but still there is low shrinkage in separate building also. Now no post curing is required, or I mean to say no post hardening is required, as the model is solid enough. It can build large part of size, I mean to say if I consider the large build volume, it is of 700 into 380 into 580. This is the particular volume they can generate. But there are some limitation with this process. What is the limitation? The part size can be in between 250 into 250 into 150 millimeter cube to 720 into 500 into 450 millimeter cube. So you can see the size, you have got some limitation, and accuracy level is plus minus 0.1 millimeter. And of course, where you are using the laser for the process, the facility cost is also too high. Now we are discussing the limitation for type 1. First of all, large physical size of the unit is required, and if you are using a large physical size unit, that means you need a big space. Next is higher power consumption is also required, and this high wastage of laser for sintering is occurring. You are obtaining poor surface finish which uses large particle powder. If you go by the limitation for type 2 EOS, then you can see it is a dedicated system which is basically used for plastic, metal and sand only. You cannot use some other material. And obviously there is a higher power consumption. You can see higher power consumption. That means higher laser power for metal sintering is occurring. Later, large physical size unit. If you are using a large physical size unit, that means you are using a large space too. So these are the application you can see in from this pictorial view. These are the very complex shape product that has been generated with the selective laser sintering process. So already in this particular lecture I have gave you a brief explanation, or I must say I have illustrated you the entire selective laser centering process of type 1 also, of type 2 also, basic principle on which it is working, what are the components that are associated with selective laser centering, what are the advantages and disadvantages for selective laser centering with respect to type 1 also, with type 2 also. And I have also explained you the application of selective lasering process in today's manufacturing world, where we are producing the various different complex type of product through these particular processes. Hope you have liked the video. So please be connected with me so that in my next lecture I can discuss about some other processes of rapid prototyping, and that will help you for your course curriculum. So please like the video, stay connected with me for my next lecture. Thank you very much.